Hello students, today's topic is hydrocarbons. Here I will solve the previous question asked in the Kcet. Question number 1. Identify B and D in the following sequence of reaction. So we'll start with the ethene. Ethene is the CH2 double bond CH2. Reacts the concentrated sulfuric acid which I split it as the H plus HSO4 minus. So we'll add H plus to one carbon atom and the negative part another carbon atom. So addition reaction to give CH3 then CH2. This will be the whole thing. I will write it as the SO3H. Okay, together. Now after that it is boiled with the water H2O. Water is a stronger nucleophile. It will attack the carbon atom containing the SO3H group. So this goes off. So we'll be getting now CH3 then CH2OH at the end. Now this compound is B. The compound B is then treated with the PBr3 phosphorus tribromide wherein the OH group is replaced by the Br group. Therefore we are going to get CH3CH2OH. CH3Br we are going to get ethyl bromide we are going to get. Finally they are given D giving the initial compound ethene CH2 double bond CH2, correct? So you have to remove hydrogen and bromine from the neighboring carbon atom. It is a dehydrohalogenation. So they will require alcoholic KOH, correct? So B is a ethanol or ethyl alcohol and the D is a reagent alcoholic KOH. Therefore answer is option number 4. Question number 2. Which of the which one of the following is an intermediate in the reaction benzene with the methyl chloride in the presence of anhydrous aluminum chloride? This is a Friedel-Crafts alkylation wherein methyl chloride reacts with the anhydrous aluminum chloride AlCl3 which acts as a Lewis acid and then produces CH3 plus methyl carbocation, the electrophile, and AlCl4 it forms. Therefore, answer is option number 4, CH3 plus the electrophile generated. Question number 3, conversion of benzene to acetophenone. Benzene is we have got with the alternate double bond single bond in the hexagon. This should be converted into acetophenone. Acetophenone is benzene attached to CH3CO group. Okay, this is a acetophenone. Now, for this we require acetyl chloride CH3COCl in the presence of anhydrous aluminum chloride. So the side product is the removal of HCl. Therefore, this is the acetylation reaction. Friedel-Crafts acetylation or generally called as the acylation reaction. Therefore, answer is option number 4, Friedel-Crafts acylation reaction. Okay. Question number 4, the correct statement is, let us see the first one, cyclohexadiene and cyclohexene cannot be isolated with ease during controlled hydrogenation benzene. Suppose I take benzene. Benzene has got alternate double bond single bond. If I make use of 1 mole of hydrogen, it should give the hexadiene like this. So when one double bond goes off. Similarly, I am going continuing this second step. So we have got here cyclohexadiene with hydrogen. We are going to get the cyclohexene probable structure, and finally the cyclohexene again can be treated with the hydrogen to give the cyclohexane. Okay. So what they given is cyclohexadiene and cyclohexene cannot be isolated. Yes, we cannot isolate. We cannot isolate first one, second one. Not possible. Directly benzene is converted into the cyclohexane. So it is not easy to separate out first two products. Therefore, first statement is correct. So need not check the other statements. Okay, right? Other statements are incorrect statements. Question number 5, electrophile that participates in the nitration benzene. For nitration, we make use of mixture of concentrate nitric acid and concentrated sulfuric acid, where concentrated sulfuric acid acts as a dehydrating agent to produce NO2 plus nitronium ion is generated. Along with that, water molecule is a side product and HSO4 bisulfate ion. So therefore, electrophile generated is a nitronium ion NO2 plus, right? Question number 6. Toluene reacts with the halogen in the presence of iron chloride to give ortho and para halo compound. Let me take a toluene, benzene ring attached to the CH3. This is toluene. So we'll carry out the chlorination. Let me give the chlorine in the presence of ferric chloride acting as the catalyst. Okay. Now this is it gives benzene attached to CH3. We can get orthochlorotoluene and parachlorotoluene. Parachlorotoluene. Okay. Remember, CH3 attached to benzene is a ortho-para directing group. It is a ortho-para directing electron donating group, and in this case electrophile generated is a Cl2 plus. Okay, it will give Cl plus and FeCl4 minus. So electrophile is added. Okay, so therefore it is called the electrophilic substitution reaction, because we are removing the ortho hydrogen atom and the para hydrogen in the form of H plus. Okay, so we H plus is replaced by the Cl plus. Therefore it is called the electrophilic substitution reaction. Question number 7. For the preparation of alkane, aqueous solution of sodium potassium salt of the carboxylic acid. Suppose I take sodium salt of the acetic acid, sodium acetate, and the solution aqueous solution water together. Now this can be converted into by electrolysis process into the alkane. So we'll get CH3 and CH3. We are going to get ethane. The number of alkyl group here, like RCOON. If I take R will double up. Okay. Side products are carbon dioxide, sodium hydroxide, and hydrogen gas we are going to get. And this is called the Kolb's electrolysis process. Okay. So therefore answer is option number 4 here. Right. Question number 8. During fusion of organic compound with the sodium metal, nitrogen present in the organic compound is converted to. During sodium fusion extract, we take sodium metal. So it will fuse with the organic compound containing carbon. Suppose there is a nitrogen in the organic compound. So all these elements combine to give sodium cyanide and ionic compound, sodium plus and Cn minus. The answer is option number 3. Question number 9. The reagent used in the following reaction is. Now this is alkyne to begin with. Alkyne is hydrogenated to give alkene. The reaction stop at the alkene, but we are not going to get alkene. Alkene is not produced. Correct? Moreover, this alkene is the similar groups are in the same side. We are going to get cis alkene. To get cis alkene, you have to make use of the Lindlas catalyst. Lindlas catalyst. What is Lindlas catalyst? Lindlas catalyst is nothing but palladium mixed with the carbon. So it is a palladized carbon it is. Okay. So answer is option number 2 here. Question number 10. 2-butane is reduced to trans-2-butene. So we have got butane CH3, C, triple bond C, CH3. So 2-butane is converted into trans-2-butene, carbon-carbon double bond. Then CH3, similar groups are there on the opposite side of the double bond, and H and H. This is the trans-2-butene. So first one is the alkyne. Alkyne is a stop at the alkene state, but this alkene is a trans alkene. To get trans alkene, first you have to carry reduction. Correct? Reduction should be there. Addition of hydrogen takes place, but in the presence of sodium in liquid ammonia. So you have to make use of sodium in liquid ammonia. Liquid ammonia. And this reduction is called the Birch reduction. This is called the Birch reduction reaction. Therefore, answer is option number 4 here, right? If you're watching for the first time, please do like, share, subscribe RD Chemistry YouTube channel and the Telegram channel. Thank you. Have a nice day.